Now let's move on to the activity of capturing and analyzing waveforms. So for that you need to first connect the input signal that we want to the oscilloscope. So right now I will actually select a sinusoidal waveform in the function generator at 1 kilohertz frequency and 5 volts peak to peak amplitude. So then I will connect it to the oscilloscope. So I have already connected it using the necessary connectors, and I have connected it to channel 1 of the oscilloscope. And after that I will press the output button, and then the waveform will appear. Again, it is not scaled properly, so I will press the auto set button to scale it correctly, and to get rid of these menus I will press the menu off. After that you need to obtain the necessary measurements. So here I have already configured the measurements for the frequency and peak to peak amplitude, but let's say you want some additional measurements such as the RMS and then etc. So again you need to go to the measure menu, and after that you can scroll through this list. So I can have multiple measurements all at once, but here I will actually select RMS. So after selecting RMS, it will be inserted into the system. So I will turn off the menus, and as you can see, even the RMS measurement is also displayed in the oscilloscope. So you can once again repeat the previous activity, that is features of the function generator and oscilloscope, change these up, and the important thing is you can display it and analyze it, especially with the measure function. That is one way you can analyze it. But there's another method to analyze a waveform. So firstly I will stop this waveform using the single button. So this is frozen essentially. Every oscilloscope has a function called cursors. Now cursors is very interesting. It is essentially used in areas where you can't use the measure function, or you want to measure specific distances in the x or y axis. So that is why you use the cursor command. So the more advanced the oscilloscope is, the more precise the cursor commands are. So you can go to the cursor menu. Now in this oscilloscope I have a separate button for the cursor, but in certain oscilloscopes it might be buried under a menu. Again, refer the manual to figure it out. And after selecting the cursor, you can see some lines started to appear, and these are actually the cursor lines. So there are 4 lines in total. You can have up to 4 lines, 2 lines for the y-axis and 2 lines for the x-axis. So you can select them from these menus that are appearing in the edge of the screen. So I want to have all 4 lines, so I will select the screen feature. I will turn the menus off, and in this oscilloscope the good thing is you have a multi-select button, so and a knob. So what I can do is I can press to change the cursor and rotate to change the position. So like that I can change it, and you can identify there's a delta reading in between 2 cursors. So in between these 2 vertical cursors there is a delta reading. So essentially that is a measurement between these 2 points. And even in the y-axis there are 2 lines, and in the middle there is a delta value. So that is the difference between these 2. So I will set the vertical and horizontal cursors to measure the frequency and the amplitude, basically the time period and the amplitude. So I will go to the vertical cursor, and so here it is actually increasing in very large amount of steps, but in this oscilloscope you have a fine option. So fine will basically enable you to have very small increments of control. That is very good, and you can be very precise, and then you can do the same for the others as well. So I will select this waveform. So I will actually start this waveform from this position. I will start this waveform. So one waveform, so this will end in here. So I will have the other cursor positioned in this place. So now this measures basically the time period, and as you can see it is having a delta value of 1 millisecond. So if you convert it to frequency, that is 1 kilohertz. So that is the time. Then you can do the same thing for the amplitude as well. So I will go to the top peak in one and I will go to the bottommost peak in the other, and I will stop here, and as you can see it will show a delta reading of 5.12 volts. So it is similar to 5 volts peak to peak that we inserted from the function generator. So this is a very interesting and intuitive way to analyze a signal, especially once you can't directly measure using the measure function. After you have analyzed the signal, let's say you want to save it. So oscilloscopes are way more advanced. You don't need to point your phone and take a picture with it. You can actually take a screenshot of what is inside the screen using a pen drive. So if I have a pen drive, I can plug it in. It's important to note that this pen drive should be formatted to either FAT format or FAT32 file format. NTFS formats will not be supported in this oscilloscope, and also certain oscilloscopes don't support certain types of USBs. You have to try your luck with that. I can insert the USB, and to save the screenshot, in this oscilloscope there's a button here called save. There's a disk button. If you press that, this will be saved as a PNG file. Or else you have something called save and recall. So this is a different menu. You can change some settings, such as you can change the format. You can go for BMP, JPEG and MPG, and you can change the formats and you can save it using this button right here. Or else in other oscilloscopes, sometimes this save button will not be there. You have to go through some menus in order to save the screenshot, but in all oscilloscopes you will have this feature. It is very important to note that just because the brand of the oscilloscope or the function generator change doesn't mean the functionality changes, because every oscilloscope and every function generator will behave exactly the same. It's just that the menus and the buttons will be placed differently. However, if you know what to look for, you can figure it out by just playing with the buttons, or else you can refer the manual of the manufacturer and search for that specific function, and that will be indicated clearly on how to access those functions. So this is an overview of how to capture and analyze waveforms generated using a function generator and measured using an oscilloscope.